Okay, let us start the class now. And today the topic is electric current, and we will be doing some numericals based on Ohm's law and laws of resistance. Different types of questions we will be doing here. It will bring confidence to do any type of questions. Okay, so let us start now one by one. The first question is, how much work is done in moving a charge of 2 coulomb across 2 points having a potential difference of 12 volt? Okay, to how to do such question. Fine. First, we'll see what are the parameters available here. First here, what is given? The potential difference across the 2 points is 12 volt. We can write here in short, potential difference means PD across 2 points. 2 points V equal to 12 volt. Okay, already given. Next, charge which to be moved in a circuit. Charge to be moved. Is it denoted by Q? Q is given how much? 2 coulomb. Fine. And we have to find out here the work done. To work done for moving the charge, for moving the charge let us denote by W, which is to be found out. Okay, so as per the formula we know work is equivalent to Q times V. We can write here W is equal to Q into V. Then put the value and we'll get the real. Q means coulomb, voltage means 12 volt, 12 to the 24, and the unit of work is joule. So here the answer will be 24 joule. Okay, this is the answer. So such type of questions will be done like this, right? Okay, next question. What is the next question? Calculate the potential difference, okay, required across a conductor of resistance 50 ohm to make a current of 1.5 ampere flow through it. Let us suppose one circuit is given. Here this is the battery and this is the resistance in this circuit. Okay, then what is given here? Potential difference to be calculated means V is equal to what? Then what? Next is given resistance value. This is 5 ohm. This is 5 ohm. Means we can write here R is equal to 5 ohm. The next parameter, current is also given of 1.5 ampere. The current will start from positive terminal and will be terminated to negative terminal here. Okay, this will be direction of the current in the circuit. So I is also given 1.5 ampere. So we can write here the given parameters. Okay, the resistance R equal to 5 ohm. Okay. The next current in the circuit, current I is equal to how much given? 1.5 ampere, and voltage, this is to be calculated here. Voltage, or we can say potential difference PD, V, to be calculated here. So as per the Ohm's law, we use the Ohm's law. As per the Ohm's law, okay, what is the equation as per the Ohm's law? V is equal to IR. Okay, I is available here, R is also given here. I means 1.5 ampere, R means 5 ohm. Okay, just calculate, it will be 7.5 volt. So here the potential difference is V equal to 7.5 volt. Okay, this is the answer. It is so simple. Okay, next question. How much current in starting itself we came to know that current is to be calculated here. How much current will an electric bulb draws from a 220 volt source if the resistance of the bulb filament is 1200 ohm? Okay, let us suppose for our simplicity we should draw the circuit diagram. This is the battery, fine. Okay, one bulb is given here. Let us suppose this is the bulb in the circuit. This is the bulb, fine. Current will flow from positive to negative terminal. Okay, this is positive, this is negative, like this. What is the potential difference? Here PD is given 220 volt, right? The next, resistance of bulb filament is also given. Here R is also given. How much? 1200 ohm. Okay, current is to be calculated. I equal to 1. Fine. So let us write once more the parameter here. Resistance, resistance, resistance of the bulb filament. Bulb filament. How much? Let us denote it by R, equal 1200 ohm. Okay. The next, potential difference or voltage. PD across it, that is to be denoted by V. How much? 220 volt. And current flowing through the circuit I is to be calculated. Current I equal to what? Same way as per the Ohm's law. As per the Ohm's law. Ohm's law. Okay. V equal to I into R. Okay. We can write here I to be calculated. I equal to V by R. Now put the value. V means how much? 220 volt. R means 1200. We have to write like this. Then just simplify it. 11 is, this is to be 60, means 11 by 60. Now just to divide 11 by 60, it will come out to be, just divide it here, 60 divided by 11 is 0, 1, 60, 0, 5, then 0, then yeah, it will go 8, 8 for the 48, 8 times. Means we can say this is 0.18. This is the current value. 18 current value will be current value will be 0.18 ampere. So you can write here I equal to 0.18 ampere. This is the answer. It is very simple. Let's move to next question. What is this question talking about? The potential difference between the terminals of an electric heater is 60 volt. Fine. When it draws the current of 4 ampere from the source. Okay. What current the heater draws if the potential difference is increased by 120 volt? Okay. Okay. How to solve such type of questions? Let us suppose this is the circuit in first condition. Means this is the voltage is potential difference here. Okay. And electric heater means this is having the resistance value. Some resistance value will be given here of this electric heater. Okay. In first condition, the voltage across this point is 60 volt, right? And current flowing through this circuit is 4 ampere. Means electric heater is drawing 4 ampere of current when the voltage is 60 volt across these points. Okay. So we can calculate the resistance value of this electric heater. Let us suppose this is R. This is R. So we can write. You can write in first condition. In first condition, okay, volt means potential difference is given. How much? It is given. It is given 60 volt. Okay, 60 volt, and current drawn by this electric heater. Current flowing. Current I flowing in this condition. I is equal to given 4 ampere. Okay, so we can calculate the resistance value of this electric heater. So as per Ohm's law, as per Ohm's law, Ohm's law, R will be equal to R will be equal to V by I. V is given here 60 volt, and what is the I value? 4. So 15 4 ja 60 means 15 ohm. This is the resistance of the electric heater. Okay, this is the value of resistance here. Okay, now in the second condition, this voltage is increased to 120 volt. Means 60 volt becomes to 120 volt. We can draw the second diagram also like this for better understanding. Okay, for better understanding. Now it has become how much? 120 volt. And resistance we have already calculated. Here R is equal to how much? 15 ohm. Oh, okay. Then what to be calculated? What current the heater will draw means I is to be calculated here in second case. Is the I. So V is given, R we have already calculated, and I we can simply calculate. In second case what will be the change value of current? Now the changed current we can say here, changed current I will be as per the Ohm's law V by R. V means 120, R means 15. Just cut it 8 times 8 ampere. So here I will be 8 ampere. See, I is equal to 8 ampere, and when the voltage is 120 volt, and in first condition when I was 4 ampere, the voltage was 60 volt. We can see it means it is proved also when the voltage is increased, the current is also increased in the same ratio. In initial condition when the voltage was 60 volt, the current was 4 ampere. Now when the voltage just doubled, means it has become to 120 volt, the current is also just multiplied by 2. It has been just doubled from 4 ampere to 8 ampere. Okay, fine. Let us move to next question. Okay. The resistance of a wire of length 5 meter is 100 ohm. Fine. If the area of the cross section of the wire is 3 into 10 to the power minus 7 meter square, calculate the resistivity of the metal. Okay, this question is related to law of resistance. What this question is talking about? One conductor is given. Okay, let us consider this is the conductor. This is the conductor. Fine. It's a cross section area. This will be the cross section area. We can say it depends upon the resistance or diameter value. Okay. What is given? Let us suppose DC cross section area is denoted by A. So A is given here 3 into 10 to the power minus 7 meter square. Okay. And now what is the length of this wire or conductor? You can say this is 5 meter. 5 meter given the length of this conductor. Okay. And resistance is also given here. The resistance of this wire is how much? R is equal to 100 ohm. It is given. Resistivity is to be calculated here. Okay. So how to calculate the resistivity in this case? As per the laws of resistance, what is the basic formula? Basic formula as per the laws of resistance is R is equal to rho L by A. Okay. Where Rho is the resistivity of this wire or material, you can say. L is the length of this wire. A is the cross sectional area of the conductor. R the resistance value. Okay. Now let us see what the parameters given here and put the value and get the result. Okay, length of wire, length of wire means L. How much is given here? 5 meter. 5 meter. Then next, cross section area already given here, already written. Cross section area. Acha, resistance of wire, this is also given here. So we can find out the value of resistivity. Okay. If R is equal to rho L by A, so we can write here rho equal to rho means just cross multiply R into A by L. We can write like this. Now put the value, whatever the values are given here. The value of R is 100 ohm and cross sectional area. How much given? 3 into 10 to the power minus 7. Okay. And L 5 meter. 5 meter is given here. No? 5 meter. Okay. Now what we have to do here? Just simplify it. 20 5 ja 100 20. It means 60 into 10 to the power minus 7. So we can write here 6. We write here 6 into 10 to the power 1 will be cut, will be deducted, will be 6. Will be 6. So rho, this is the resistivity. Resistivity is denoted by rho is 6 into 10 to the power minus 6. What is the unit of resistivity? Ohm meter. Ohm meter is the unit of resistivity. So this is the answer. So such type of questions we have to do like this. Okay. Next question. Let's see. Resistance of a metal wire of length 1 meter is 26 ohm. This is ohm. Okay. At 20 degree Celsius. If the diameter of the wire is 0.3 mm, what will be resistivity of the metal at that temperature? Okay, here resistivity is to be found out. Okay, let's show one conductor here or wire. We can say wire or conductor, all the same. Okay, this is the wire with thickness is shown like this. Fine. What is length of this wire? 1 meter is given here. We can show here the length of this wire is 1 meter. Okay. Okay, next. The resistance is also given here. Resistance of this wire. Dia is also available. Diameter of the wire is 0.3 mm. Here its dia is given D. D is equal to how much? 0.3 mm. So it is to be converted into meter. So what we have to do? 0.3 into, it will to be multiplied by 10 to the power minus 3. It will become meter. So this is the diameter. So how to find out the R value? Means radius of this wire. because it is given in cylindrical form. R will be equal to D by 2. We can write here 0.3 into 10 to the power minus 3 by 2. Okay, millimeter. This is the value of R. Why we have calculated R? Because we have to find out the cross sectional area of this wire. How it is given? Cross section area of this wire A as per the formula pi R square. So we can write here pi D by 2 whole square. Okay. So pi, how much given? Pi means the value of pi is 3.14. We can write down here directly because 3 by 4 means 22 by 7. 22 by 7 pi. 22 by 7. Okay. Okay. This is the ratio of what? This is the ratio of, just for better understanding, if this is the circle, okay, and this is the diameter D. If this is the ratio of, this is circumference divided by the diameter. We have to remember like this. This is circumference. Circumference of the circle, and this one 7. This is diameter. Short form of diameter I have written here dia. This is fixed 22 by 7. Just divide 22 by 7. It will come out to be 3.14. Fine. So 3.14 and write down here d by 2. What is the value of d by 2? We can write here 0.3 into 10 to the power minus 3 by 2 whole square. Fine. So just this is simple calculation. 3.14 into how much? 0.9 by 4 into 10 to the power minus 6. We can write down like this. We can write down like this. Okay. So now what we have to do? Just multiply this value of 3.14 into 0.9 by 4. How much it will come? 9 4 ja 6, 6 9 1 ja 2, 28. 28 by 4. 1 2 3. Here it will come into 10 to power minus 6. Just divide. It will come out to be 7.06 into 10 to the power minus 8. This is area, means its unit will be in meter square. So we have calculated the value of cross sectional area of this wire. Okay, and what is the formula? Basic formula as per the law of resistance. R is equal to rho L by A. Fine. So what is given here? Resistivity is to be find out. This value is to be find out. This is what? R is already given 26 ohm. Length is given already 1 meter. And cross sectional area we have already calculated here. Okay. So how to calculate the value of rho here? We can write down here. Now rho is equal to how much? R A by L. Put the value. R how much given? 26 ohm. Area we have calculated how much? 7.06 into 10 to power minus 8, and L 1 meter is given here. Just multiply it. This will come out to be 26 into 7, 6. Yeah. This will just simplify it. It will come out to be 1.84 into 10 to power minus 6. This will be ohm meter. So resistivity R equal to 1.84 into 10 to power minus 6. Its unit is ohm meter. This is the answer. We have to do like this. Okay. Next question. The specific resistance of nichrome here already rho is given. Okay. 100 micro ohm. This is micro ohm. Okay. What will be the resistance of a nichrome wire of 5 meter, length is given, and 0.01 centimeter square area of cross section? Okay. Just we should draw one, this one conductor which is made of nichrome here. Okay. And what is given here? We'll see the cross section area is how much? Here it is given cross section area. Cross section area is given here in centimeter square. This one means A. This area is given A. How much? 0.01 centimeter square is given. So what we have to do here? This is to be converted into meter square. This is also the task in this case. Okay. And what is the length of this nichrome? Means L is equal to 5 meter is given here. And specific resistance means rho is also given here. Rho how much given? Specific resistance as per the question. This is called resistivity or specific resistance, all the same. Rho is given here how much? 100 micro ohm. Micro ohm is given here. Okay. Then length. How much length is given? Length is 5 meter. See, we have to see here for solving this question, what will be better to convert from meter to centimeter or from centimeter to meter? Here the area is given in centimeter square. Okay. And length is given here in meter. I think it will be better to convert meter into centimeter or simplification. We can write here 5 meter into 100 equal to 500 centimeter. Okay. Because area is given here in centimeter square, 0.01 centimeter square. Okay. Now as per the law of resistance, as per the law of resistance. What is the basic formula? R is equal to rho L by A. Okay, we have to find out here the value of what? What will be the resistance of nichrome? R directly asking for the resistance value. Then directly we can put the value. Rho value is already given. How much? Rho is 100. See, it is already given in micro ohm. We have to remember here micro ohm. Okay, L 500 centimeter and area 0.01 centimeter square. So just solve it. How much it will become? It will 5 into 10 to the power 4 by 0.01 micro ohm. Okay, further we can solve this. 5 into 10 to the power, it will become 6, 10 power 6 micro ohm. Just divide by 10 to the power 6, it will come out to be 5 ohm. Okay, what is the right answer? R is equal to 5 ohm, which is to be calculated. This is the answer in this case. Okay, fine. Next, two copper wires A and B of length 30 meter and 10 meters have radii 2 centimeter and 1 centimeter. Fine. Respectively, compare the resistance of the two wires, which will have less resistance. Okay? It is to be find out what is the resistance value. We have to compare which one is bigger or which one is less. First, we have to draw one just for simplicity for us, because here two wires are given having different radii, means radius is differing here. One is having just double of another, you can say. Okay, let us suppose these are the two wires having different in radius. Its radius is, let us suppose its radius is 2 centimeter, and here its radius is 1 centimeter. Okay, length is also given here. It is having bigger one. We can extend it further. This is 30 centimeter, 30 meter, 30 meter, and this one is 10 meter as per the question. Okay, let us suppose this is 10 meter. Resistance is to be compared here. Okay, first we can write here what is the given as per the question. First parameter is to be written for more clarity. Let us suppose the length of the first wire is L1, which is equal to 30 meter. We can write here 30 meter. Okay, how to write the cross sectional area of this wire? First one. Okay, we can write here pi its radius is, let us suppose, r1. We can write a is equal to pi r1 square. Fine. So we can write here, this is pi we just pi r1, how much given in first case, 2 centimeter, to be converted into meter. 2 into 10 to the power minus 3, we can write here pi r square. Okay, this is in meter square. Fine. Okay, similarly we can calculate for the L2 also. Means next one, L2 whose length is 10 meter and cross sectional area we can find out for this one also. Let us have it. This one for A1 and for A2. Same way, pi means R2 square we can write here. Okay, so pi R2 means R2 how much given? 1 into 10 to the power minus 3 whole square. It has become in meter square. Okay, this much we can write. We know the basic formula for R as per the law of resistance, R equal to rho L by A. We can write here as per basic formula. Basic formula we can write here, means R1 is equal to rho L1 by A1. We can write here. Similarly, for R2 we can write, and similarly R2 we can write rho L2 by A2. We can write like this because we have to just compare the values of resistances of both the wires. So for comparison we can write here, so R1 by R2 we have to calculate, means we are going for comparison. R1 by R2, R1 in place of R1 we can write here now rho L1 by A1 by, let us see how much the value of R2, rho L2 by A1. L2 by A2 na? A2. Okay, fine. It will be cancelled out. Okay, fine. So how much it will become? L1, this will go up A2 by L2 A1. We have to write like this, and whatever the value is given, we can just put the value and get the result. L1 means 30 meter, 30, and A2, what we have calculated here, this is the value of A2, means pi into 1 into 10 to the power minus 3 whole square, and L2 is given 10 meter na? 10 into pi, this one 2 A1 means 2 into 10 to the power minus 3 whole square. Okay, just cut it, simplify it and get the result. This pi and pi will be cancelled out. Okay, 0 and 0 out. So we can write here 3 into 10 to the power minus 6 by 4, 2 to the 4, 4 into 10 to the power minus 6. It will be cancelled out, means 3 by 4. Okay, means R1 by R2 equal to 3 by 4. See, just corresponding to R1 the value is 3 and for R2 it is 4. This means R1 is lesser than R2. We can say R1 is less than the resistance value of R1, that is first wire is less than R2. Okay, so this is the answer. Okay, next question. A piece of wire of resistance 20 ohm is drawn so that its length is increased to twice of its original length. Calculate resistance of the wire in the new situation. Okay, very fine. The resistance of a wire, let us suppose this is one wire is given here. It must be habituated to draw the diagram in any case, and especially in physics it is must for more clarity. So this is the wire. Okay, this is the cross sectional area. Right? What is given here? The resistance of this wire is given 20 ohm. Fine. So that its length increased to twice of its original length. Okay. Now this L is increased to new value of L2, just double. Calculate resistance of the wire in the new situation. In that situation, let us suppose earlier the wire was like this, just half of it. Just half of it. Half of it was the, okay, this was the wire in earlier case. Now it will be stretched in this bigger form like this. Okay. Now what is the value given here? Just write down here. First, what is the value given here? R. R is 20 ohm. Okay, fine. And as per the basic formula, as per formula, what we can write here? R equal to rho L by A. Okay, and whatever the value is given, we can write here. What is the value of R? R value is 20 ohm. We can write here, means 20 means rho L by A is equal to 20. Okay, now the length has become twice and cross sectional area has become half. It has to be. Now the length has become twice. Then its cross sectional area will be half of it. Okay, so in new scenario, what will be the value of resistance? R new, same formula, rho L by A. Rho L by A. L means twice of L. it has just become double. Okay, A means it has become half. We can write down here A by 2. Just put the value, what the value is given here. Okay, so this 2 will go up, means 2 into 2 into rho L by A. Fine. See, rho L by A, this value is given here. We can see this value of rho L by A is 20. So we can write down here 2 2 ja 4. 4 into this one 20. 20. It will be 80. Resistance value ohm. So new resistance value will be new scenario, new situation will be 80 ohm. So new resistance, we can write new resistance is equal to 20 ohm. This is the answer. Fine. Next, and I think this is the last question. Calculate the area of cross sectional of a wire. Okay, means cross sectional area means A to be calculated. If its length is 1 meter, its resistance is 23 ohm and resistivity of the material is this much ohm meter. Very fine. Just this is very simple. Just write down the parameters, what are the given here, and use the basic formula and simplify it and get the result. Very simple. What is given here? Here. Okay. Here. For simplicity, as I told, we must draw one wire. For better understanding, it must be habituated. It makes the physics very easy to understand because it gives the physical appearance. See here, this is the cross sectional area. This is A area. How much it is given? It is to be calculated. Calculate the area of cross section. This is to be calculated. What? Then other parameters is given. What is the length of this conductor? Length of this conductor or wire, we can say this is 1 meter. L is equal to 1 meter. Fine. Next parameter, resistance, its resistance R is also given. How much? 23 ohm. Okay. Next, resistivity. Resistivity is also given here. 1.84 into 10 to the power minus 6 ohm meter. And we can write here also here the given parameters. Okay. What is given here? L, we can write here 1 meter. Then R is 23 ohm given. Rho is also given 1.84 into 10 to the power minus 6 ohm meter. Ohm meter. Then as per basic formula, as per law of resistance, that is the basic formula, R is equal to rho L by A. Okay. This is the basic formula. What is to be calculated here? We have to calculate the cross sectional area. A is to be calculated. Can you write like this? A is equal to rho L by R. Fine. we can write like this and put the value. What is the value of rho? 1.84 into 10 to the power minus 6, L 1 meter, and R 23 ohm. Okay, so what to do now? It means 1.84 divided by 23 into 10 to the power minus 6. Just we divide this value, this one, it will come out to be, just simplify it, it will come out to be 8 into 10 to the power minus 8 meter square, because we have calculated the cross sectional area. A means cross sectional area of this wire is 8 into 10 to the power minus 8 meter square. Okay, this was the last question. We have done different type of questions because practice is must for having much more confidence. Okay, do practice and get confidence more and more. Okay, thank you.